Okay, so for this first problem, we see we have the cube root of 6 to the 4th power, and we know we can write the cube root as the 1/3 power, and when we have a power to a power, we multiply them. So we should have 6 to the 4 over thirds, or 6 to the 4 thirds, or 4 over 3. Now, this is where our power over root rule comes from. But when we have, as you can see in number 3, which we're going to go to that one first instead of number 2, we have more bases than just one. So we'll need to use this extra step, and the power over root rule won't work just quite as easy. So what I'm going to do is I'm going to take everything inside the root and put it in parentheses, and then raise it to the 1/3 power because it's a cube root. Now, when I have multiple things to a power, I have to distribute that power. So now I have 125 to the 1/3 power times x to the 6th to the 1/3 power times y to the 9th to the 1/3 power. Now, when I have 125 to the 1/3 power, that's the cube root of 125, which should be 5. And x to the 6th to the 1/3, I multiply my powers and I get x to the 6 over 3. 6 divided by 3 is 2, so I'll have x squared. And y to the 9th to the 1/3, we multiply the powers, I get 9/3 as my power, which is just 3, so I have y to the 3rd. Now, number 2 gets a little crazier. Remember, when we have a square root, there's this implied 2. So I know I can take everything under the radical, put it in parentheses, and raise it to the 1/2 power. Now I need to distribute my power to every single one of these. And we've got lots to do here. So we have 9 to the 1/2 power, x to the 12th to the 1/2 power, y to the 4th to the 1/2, x squared to the 1/2, y to the -8 to the 1/2, and now we simplify. So 9 to the 1/2 is the square root of 9, that's just 3. X to the 12th to the 1/2, we divide 12 by 2, we get 6, so x to the 6th, because we multiply those powers. Y to the 4th to the 1/2 would be y squared. X to the 2 over 2 would be just x to the 1st, so we don't have to write that 1. And y to the -8 divided by 2 is y to the -4th. Now, the only thing I need to change, the last thing I need to do is just deal with this negative exponent. So a negative exponent says move to the denominator. So I have 3x to the 6th y squared times x over y to the 4th. And I misspoke. I do have one more thing I need to do, and that is combine some like terms. We'll use our exponent rules for this. So for my two x's, I'm multiplying. They have like bases, so I'm going to add their exponents. This x technically has an x to the 1st. So x to the 6th times x to the 1st is x to the 7th. And then for my y's, when I divide like bases, I subtract their exponents, so I should have y to the 2 minus 4. So my final answer here will have 3x to the 7th, y to the -2. I don't like negative exponents, so it goes to the basement. 3 times x to the 7th over y squared is our final answer. So green light, final answer. All right. Now let's look at number 4. I see my 4th root. I can rewrite this as an exponent, x to the 12th to the 1/4. And then in the denominator, I have the square root, so I'm going to have x to the 4th to the 1/2. Power to power rule says I multiply exponents, so 12 times 1/4 is 12 fourths. 12 divided by 4 is 3, so my exponent is 3. And then in the denominator, 4 divided by 2 is 2. When I have like bases and I divide them, I subtract exponents. So I have x to the 3 minus 2. That's x to the 1st, which is just x. So that one didn't turn out too bad. Looked a little hairy, but it got better. All right, now if we want to go from exponential form to radical form, this is where we're going to use our power over root rule the most. So power over root, you remember it's always power over root. So here my power is the 4 and my root is the 5. So I now have the 5th root of x to the 4th. And just one more time here, I know I have power over root. So my power, I know I have the 3rd root of x, and my power is -2. Now, we don't want to have a negative exponent, and that says I need to move it to the denominator, but I still have this cube root. So now I have this cube root of 1 over x squared, and I know the cube root of a fraction is the cube root of the top over the cube root of the bottom. And the cube root of 1 is just 1 because 1 times 1 times 1 is 1, and that's the definition of a cube root. Now, I see we have a radical in the denominator, and that radical is a cube root, so we're going to leave it as is because we only practiced rationalizing the denominator with square roots, so you'll see another video for practice with that topic.